In this video, we shall do some of the numericals on chemical kinetics. So let us start the video with our first question. And our first question is that for a reaction A plus B gives us P is the product and A and B are the reactants. The rate law is R is equal to K, A raised to the power half and into concentration of B raised to the power 2. Then what is the order of reaction? See, you have studied that order of reaction is the total of the powers of reactants, that is power reactants in rate law. So here the power is R, rate of reaction is R constant A half B square, and order will be sum of the powers of the concentration of reactants. Then it is half plus 2, and that is equal to 5 by 2 and 2.5. So this is the order of reaction. So this is the solution of the first question. Order of reaction is 2.5. Now we come on to the second question. This is the equation, chemical equation. A is the reactant and it is converted into products. P is the product. And concentration of A decreases from 0.5 mole per liter to 0.4 mole per liter in 10 minutes. Time is given 10 minutes. Calculate the rate during this interval. See, here rate of reaction is equal to change in concentration divided by concentration of reactant divided by time taken, and this will be equal to minus half delta A divided by delta T. Decrease in concentration of A divided by time taken, and minus half. Why minus half? Because this is coefficient, stoichiometric coefficient is 2. So it will be multiplied by half. And this will become minus half final concentration minus initial concentration, this divided by T2 minus T1. See, at T1 the concentration of A is 0.5 mole per liter, and at T2 the concentration becomes 0.4 mole per liter, and time is T2 minus T1 is 10 minutes. So we say that it becomes minus half 0.4 minus 0.5 divided by 10, and this becomes minus half into minus 0.1 divided by 10, and when we calculate it, it will be 5 into 10 raised to the power minus 3 mole per minute. So this is the solution of the question. The rate during the interval will be 5 into 10 raised to the power minus 3 mole per minute. Now we come on to the third question. And the third question is, a first order reaction has a rate constant K is equal to 1.15 into 10 raised to the power minus 3 per second. And here initial concentration of reactant is 5 gram. See, a first order reaction has a rate constant. Rate constant is given, and how long will 5 gram of reactant will take to reduce to 3 gram. So initial concentration of reactant is 5 gram and final concentration is 3 gram. K is given, then we have to calculate T. So T is given by formula 2.303 K log of R naught initial concentration oblique final concentration. So this becomes 2.303, constant is 1.15 into 10 raised to the power minus 3 log of R naught is 5 gram and this is 3 gram, 5 by 3. It becomes 2.303 1.15 into 10 raised to the minus 3 log of 5 by 3 becomes 0.2219 and this comes 444 seconds. This is the solution of this much of time will be taken by the reactant to reduce its concentration from 5 gram to 3 gram. This is the solution. Now we come on to the fourth question, that is time required to decompose SO2Cl2 to half its initial quantity is 60 minutes. So means T half is equal to 60 minutes. And if this is a first order reaction, calculate the constant of reaction. Then for T half, constant first order reaction constant is 0.693 into T half. This is for first order reaction. So K here constant of reaction is to be calculated. K is to be calculated 0.693 into 60 minutes. And when it is converted into seconds, 60 into 60. And when we calculate it, it will come out to be 1.925 into 10 raised to the power minus 4 per second. Because this is constant and here second will come per second will be second inverse will be the unit of K. This is the first order reaction. Now we come on to the next question, fifth question, and that is determine the order of reaction and dimension of rate constant in these chemical reactions. First reaction is 3NO gives us N2O and rate is K into NO, concentration of NO raised to the power 2. As it is 2, so order of reaction is 2. Order of reaction is equal to 2. Second order reaction. This is second order reaction. Because in the rate law, what is the power? Sum of the powers of the concentration of reactant is order of reaction. So it is 2. Now we have to calculate dimension. How will you calculate dimension of rate constant? That will be K is equal to rate divided by NO square. Rate is mole per liter per second, and concentration, unit of concentration is mole per liter, and as it is squared, so it is squared, and that will be, if we calculate it further, we see that it will be here, this will be same, these are the same, and but it is here too, then it will come mole minus 1 liter second. This will be the, because this will cancel out with what will mole minus, this will come in the numerator, and the unit will be, dimension units will be this. And same we can calculate it as order, here order of reaction, same 3/2, and rate is, dimensions of K will be rate CH3 CHO 3/2. So rate is mole per liter per second, and here mole per liter 3/2. And if we calculate it further, it will come as mole liter mole 3/2 liter 3/2 minus 3/2, minus 1 into 3/2 minus 3/2, and if we calculate it further, it will be mole it will come again in the numerator, it will become mole 1 minus 3/2 liter minus 1 plus 3/2 and second minus 1. Okay, then this will become mole 1 minus 3/2, it will become minus half, and liter minus 1 plus 3/2, it will become 1/2, and so this will be the dimensions of the rate constant. Now we come on to the sixth question, and as there is no space, I will take a fresh page to calculate this. Sixth question is, there is a reaction 2A plus B. This is the product. Now rate is R is equal to K A B to the power 2. Now we are given K, value of K is equal to 2 into 10 raised to the minus 6 mole liter 2, and calculate initial rate of reaction. Initial rate of reaction when A is equal to 0.1 mole per liter, and B is equal to, initially it is equal to 0.2 mole per liter. Now how can we calculate it? And rate, this is initial rate of reaction, one thing we have to calculate initial rate of reaction, and second is rate after A is 0.06 mole per liter. So these two things are we have to calculate. So how shall we calculate? See, here we are given K, and first reaction will be, how can we calculate? R is equal to this formula, initial K is 2 into 10 raised to the power minus 6, and initially it is A, concentration of A is 0.1, concentration of B is 0.2, and this is the, this will come out to be, if we calculate it further, it will be come out to be 10 into 10 raised to the power minus 9 mole per liter per second. This is the initial rate of reaction, and let it represent by R0, initial rate, and then we calculate our final rate after concentration of A is 0.06 mole per liter. Then it means if A concentration of A is 0.06 mole per liter, then what is the amount of A consumed in the reaction? Consumed in the reaction. This will be 0.1 minus 0.06, because 0.1 was initial concentration and 0.06 was after the reaction. So the quantity of A consumed is 0.04 mole per liter. Okay. Now if concentration of A consumed is 0.04, then concentration of B consumed or consumed in the reaction will be half of 0.04, half of the concentration A, because it is concentration of, in the rate reaction, in the rate law, it is B square. So it will be consumed half of the concentration of A. So it B consumed will be half into 0.04, and that will be 0.02 mole per liter. This is the consumption of B. And how much B left? B left will be, initial was 0.2 minus 0.02, and that will be 0.18 mole per liter. Now we have got concentration of A after the reaction and concentration of B. Then now we have to calculate the rate of reaction, final rate of reaction. Let us represent it by RF. That will be, again K, value of K is 2 into 10 raised to the power minus 6, and concentration of A is 0.06 and concentration of B is 0.18 square, and that will be equal to, if we calculate it further, this will give the 3.89 into 10 raised to the power minus 9 mole per liter. In this way, we have calculated the rate of reaction after the mole concentration have been consumed in the reaction. So this is the solution of the sixth question. Now we come on to the seventh question, that is the decomposition of ammonia on platinum surface is zero order reaction. This is given zero order reaction, and reaction is 2NH3 on platinum. It will give N2 plus 3H2. This is the reaction. Zero order reaction. This is zero order reaction. Here, what are the rates of production of N2 and nitrogen and hydrogen if K is equal to this? See, rate constant, rate law will be minus half d NH3 by dt. This will be equal to d N2 dt. This will be equal to 1 by 3 d H2 divided by dt. This is the rate law in this zero order reaction. So for zero order reaction, this is equal to K. This is equal to K, 2.5 into 10 raised to the power minus 4. So we have to calculate production of N2. Rate of production of N2 कितना हो गया? This will be equal to 2.5 into 10 raised to the power minus 4 equal to rate constant. It will be equal to constant. Per second. This is the rate of production of nitrogen, and rate of production of hydrogen, it will be equal to 1 by 3. Sorry, here 1 by 3, it will come here 3 into 2.5 into 10 raised to the power minus 4, which is equal to 7.5 into 10 raised to the power minus 4 mole per liter per second. So this is the production of, this is the solution of the question. Now our 8th question, and that will be the last question in this series. A reaction is second order reaction with respect to a reactant. How the rate of reaction will be affected if concentration of reactant is doubled or reduced to half? This is a very interesting question. Let us take some fresh sheet to calculate it. See, R is equal to K A की power 2. Why? Because this is a second order reaction. This is a second order reaction. So rate law will be given by this. Let us say that its concentration is X. So it will become Kx square. Now concentration becomes doubled, 2x. Then R2 will be K 2x whole square will be 4k x square. Then what is the change in rate? It will be 4 times. 4 times, because 4kx square by kx square, R2 divided by R1. So it has become 4 times. So this will become 4 times if the concentration of the reactant is doubled. And the second part is, if it is reduced to half, then what will happen? अगर हाफ कर दिया जाए, then it will become, concentration of A will become x by 2 and rate will become k x by 2 whole square, and that will be k x square by 4, 1 by 4 k x square. then it will be reduced 1 by 4 times. So this is the solution of the questions. Thank you for watching the video.